Next, we have arithmetic sequences. An arithmetic sequence is a sequence in which each term is generated by adding or subtracting a common difference to the previous term. We encountered some arithmetic sequences in yesterday's work as we were introducing sequences. Today, we're going to specifically look at just those which require us to add or subtract each time. So here we have an example of 5, 6.5, 8, 9.5, and 11. And now we have some decimals in there, which is different than yesterday. But here, in this particular sequence, each term is generated by adding 1.5 to the previous term. The same common difference must be used every time for it to be an arithmetic sequence. Also, with arithmetic sequences, we would use a linear model. So here, this looks a lot like mx plus b, except we're using t of n and n as our variables. That's function notation. You should be familiar with that. That can be used to represent an arithmetic sequence. The m value is the growth of the slope and is representative of the common difference while the sequence, while the b value is the starting value or term 0 of the sequence. So in this example, we have t of n equals 1.5n plus 3.5. So 1.5 is our common difference. That's what we had to add each time. That was our rule. The 3.5 doesn't appear in this sequence. Okay? Because when we read this sequence, we assume that the 5 is the first term, and the 6.5 is the second term, and the 8 is the third term, and so forth. So for us to get the 0 term, we have to go backwards one time from our first term. So if I take 5 minus 1.5, so backwards from addition would be subtraction, I get 3.5 for my term 0. Let's take a look at a couple examples. Write the next 3 terms of each sequence, and then write a rule for each sequence. So in this first example here, I have 1, 5, 9, and 13. I'm looking for that common difference. In this particular case, it appears to be 4. So I'm going to add 4 each time to get my next 3 terms of 17, 21, and 25. Now when I write my rule for this, a of n, since it's arithmetic, my common difference is 4n plus, but term 0, if 1 is my first term, I must go backwards one time to get my 0 term, and in this particular case, that would end up being negative 3. 1 minus 4 gives me negative 3. And go on to my next example. In this particular case, I have 45, 34, 23. So here, my sequence of numbers is actually decreasing. That should tell me something about my common difference. That should tell me it's going to be a negative number. What negative number will that be? Well, 45 minus what gives me 34? That answer would be 11. Does that apply? 34 minus 11, 23? Sure. So I subtract 11 from 23 and I get 12. I subtract 11 from 12 and I get 1. And then negative 10. Write my rule. So b of n equals negative 11. Since it's going down, I want the negative to represent decreasing, and I must go backwards 1 to get my 0 term. Well, if subtraction is my rule, backwards would be addition. So if I add 11 to 45, I would get 56. So plus 56 from my term 0. Last, I have some decimals, everybody's favorite friend. So my first term is 1.4, my second term is 1.7, my third term is 2. What is the common difference here? In this particular case, it happens to be a decimal value of 0.3. So my next 3 terms will be 2.3, 2.6, and 2.9. And if I wanted to write that rule, I would have C of n equals 0.3, my common difference, n, and then I must go backwards 1 to get my 0 term. So 1.5 minus 0.3 gives me 1.1. So plus 1.1. And there is arithmetic sequences.